Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day here in my virtual classroom. If you step on inside, we are in our Big Ideas Math Integrated Math 2 textbook, looking at section 4.7, solving quadratic equations with complex solutions. Now, in chapter 4, we've solved quadratic equations using every method, not just chapter 4, but chapters before it, because we've solved by factoring in the past, using factoring and zero product property, and hopefully this, if we have some non-complex solutions, hopefully we can still use that method. But we have other methods now. We've solved by graphing, which I don't know if we're going to get into that much in this section. No idea. Solving using square roots, solving by completing the square, and solving with quadratic formula. But we've only looked at real solution sets, whether it was two real solutions, which is most often, or one real solution. And if we have no real solutions, we tended to just say no real solutions and moved on from there. But in section 4.6, we started to learn about complex numbers and imaginary numbers, taking square roots of negatives. So now when we have a discriminant, say in the quadratic formula, discriminant of a negative number, or we take the square root of a negative number when we solve by completing the square using square roots, we will continue by using that I. I always go to the sign language, the I, but we'll go to that I portion of this and use that in our solutions, this plus or minus port with complex conjugate solutions, and we will have those and use those and go with those here. Now, I don't know what kinds of problems we're going to have. I know it's only up to number 41, so I hope it's kind of a smaller bit. You'll know how long this is already, but I have no idea. Hopefully it's a smaller bit, not too many word problems here and there, and hopefully we get to choose our own method, because my goal is I'm going to be choosing the method that I think is going to be best for us, or for me, and use that and say this is why it should be best for you as well, I suppose, given what we've done. All that being said, there is a lecture portion. We'll see what it includes. But if it's basically, to me, when I teach this, I say, hey guys, we're solving like we always solved before. But if we have a negative square root that we take, we just simplify it with I and we just keep moving forward. But we'll see what other kinds of questions that they have. Anyway, there's a bit of an intro. The point of the intro here is that everything we learned beforehand will apply. So I'm not teaching the old stuff again. I'm just incorporating it into the new stuff that we have here. So I reckon anything from 4.3 to 4.6 is really important for complex solutions. Okay? Okay, let's go ahead and move forward and look at the lecture portion, see what they have to offer. I'll probably go pretty quickly through this stuff if there's not much new. We're going to solve quadratic equations and find zeros of quadratic functions. All that same stuff, only now I'm expecting a lot of complex solutions with imaginary numbers, and use the discriminant. That's the b squared minus 4ac portion of our quadratic formula. Also not new. Previously, you learned you can use the discriminant to determine whether there's 2, 1, or 0 real solutions, but when we had no real solutions, we stopped, or that's all we said. But now we can use the imaginary unit I to write two imaginary solutions, this plus or minus something I, so we will move forward from that. So they all have some complex number solutions, and we will always use them. There's something called the fundamental theorem of algebra that we won't dive into until, I guess, IM2, Integrated Math 3, where it kind of says that all quadratic equations kind of have two solutions if you think about two real solutions, two imaginary solutions, or the one real solution with a multiplicity of two, what they call a repeated root. Anyway, now we're going to solve with imaginary solutions. Let's look at this, and it looks like they're doing the use any method. Use the method that makes the most sense. This first one, I would solve by using square roots. Subtract 9 and take the square root of both sides. And when you take the square root of both sides, you get plus or minus the square root of negative 9, which is plus or minus 3i. Square root of 9 is 3, square root of negative 1 is I. That goes to section 4.6. So here are your two solutions, the plus or minus portion. That is part A. Part B, I have x squared plus 4x plus 5 equals 0. Non-factorable, but you can solve by completing the square, and it looks like that's what they do. That's the method that I would go by, completing the square. Subtract the 5 over, complete the square, add 4 to both sides, but you see this is a negative 1 when you factor this thing down, so we do take the square root of both sides, and the square root of negative 1, not being real solutions, we'll have imaginary solutions of I. So square root of negative 1 is I, so subtract the 2 over, you get negative 2 plus or minus I. Negative 2 plus I, negative 2 minus I being your two imaginary solutions. The last one, part C, 5x squared minus 4x plus 1 equals 0, also not factorable, but I wouldn't use completing the square because this a is not 1, so they're going to use quadratic formula here. I don't know why the plus or minus never comes out on their typing format, but we've seen this before, so I got to add it. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, negative 4 squared, the b squared minus 4ac becomes negative 4. That's your discriminant. Negative discriminant means no real solutions, but that means 2 imaginary solutions. Square root of negative 4 is 2y, so we will add and subtract 2y here. Now, all of these can divide by 2, so we do work fraction reduction. 4 over 2 is 2, 2y over 2 is I, and 10 divided by 2 is 5, so 2 plus or minus I all over 5. And that's pretty much what I'm hoping a lot of these problems are like. We can just use those. I mean, I assume we're going to do a lot of word problems as well, but that's the crux of what we're doing. Using the same methods, and it looks like we can choose, which is really nice. Choose it, choose it, choose it. Okay, so this is, this is the same stuff. So finding zeros of a quadratic function, you set this equal to 0 and solve. So it's no different from the previous problems. You just got to know to turn that into 0 when you do it. So they're going to solve using square roots for this problem. Subtract 20, divide by 4, take the square root of both sides with the plus or minus, and you get plus or minus I root 5. Now, I don't know if all of these are going to have only complex solutions. Maybe every so often you just have real solutions to remind yourself. Guys, you don't just put I in an answer just because. You put I in an answer because you take the square root of a negative. I'm not going to solve these ones here, but the methods, I would solve this using square roots. I would solve this by, assuming these are not factorable, I'd solve this by completing the square. I'd solve this with quadratic formula. I'd solve this using square roots. I'd solve this using square roots. I'd solve this by completing the square. So it just depends, hopefully you know the square root ones is when there's no x term. Completing the square when I have a 1x squared and an even term, and quadratic formula for the other ones. But that's what I'd go for. And maybe that's what they're going to let us do as well. So using the discriminant, b squared minus 4ac, find a possible, okay, so they're going to do something a little different here, a little more, not open-ended, but a little more exploration. Find a possible pair of integer values for a and c, so this equation ax squared minus 4x plus c equals 0 has 2 imaginary solutions. Now we had, I think section 4.5 in that 3-hour video, we had questions kind of like this before, and I don't know if what I wrote was fantastic. Oh yeah, this is open-ended. This is open-ended. Your b squared minus 4ac has to be less than 0 to have imaginary solutions. It has to be a negative discriminant. So negative 4 is your b. 16 minus 4ac. Subtract 16 divided by negative 4. Notice when you divide by a negative, the inequality flips. So your product of a times c has to be greater than 4. That means that a and c have to be the same sign. They can both be positive or both be negative. And the product just has to be greater than 4. So 4 and 2 for a and c, or negative 4 and negative 2, things like that. You can come up with your own numbers, and it looks like you can make your equation based off that. They showed if a is 2 and c is 3, it works out, and that's the equation that you'd write. Because 2 times 3 is greater than 4, that's 6. So it looks like we're going to see some problems with that involving the discriminant, and kind of more of an open-ended process. Then we have a word problem. The function here is used to model the height of a dropped object. So here's your gravity portion, and here's the initial height. Here's the height after time t. T is the time in seconds and initial height there. For an object that's launched or thrown, an extra term v naught t must be added to the model. So here, initial velocity. We've seen a lot of these actually in the past, whether or not you remember it. But negative 16 is part of your gravity acceleration component. Here's initial velocity component. Here's your initial height component. The value of v can be positive, negative, or 0 depending on whether object is launched upward for positive, downward for negative, or parallel to the ground for 0. Parallel can mean it can shoot outward, or you can let go of it. What are they going to ask us to do? A juggler tosses a ball into the air, so tosses it. That's going to be positive velocity. Leaves the juggler's hand 4 feet above the ground. That's your initial height. So you're going to see an initial height here of 4 for S naught right there. Boom. And initial velocity of 30 feet per second, it'll be positive 30, so initial velocity v, and negative 16 is your gravity bit. So, does the ball reach a height of 25 feet and 10 feet? Explain your reasoning. You're basically trying to figure out whether you get a positive or 0 discriminant, or whether you get a negative discriminant when you set your height equal to these. When height is 25, do we get a positive, negative, or 0 discriminant is the question. Now, you got to subtract 25 over before you do any sense of what we do. They went straight to quadratic formula. I'm going to do a lot less than that. I'm just going to use b squared minus 4ac. If b squared minus 4ac, the discriminant is positive or 0, then that means that you have real solutions, and that means that it intersects with that height, which means that it reaches that height. Does it reach 25 feet? With the discriminant of negative 444, no, it doesn't reach that height. Discriminant that's negative means no intersection, no solution. You can kind of see where that parabola does not hit with that line. Does it reach 10 feet? Set the height equal to 10, subtract the 10 over, use the discriminant. Again, they go whole quadratic formula. Discriminant's all that matters for me, right? The discriminant is 516. Doesn't matter what the number is, it matters that it's positive or 0, because if it's one of those, that means it has real solutions. 1 or 2 doesn't matter. The point is, it reaches 10 feet. It goes above it, but it reaches 10 feet. You could also find the vertex. You can use negative b over 2a, figure out if the height of the vertex is higher than 25 or equal to 20, things like that. But this is just one version of what we can do. So it does reach 10 feet. It doesn't reach 25 feet is our conclusion we can make. All right, that's the lecture portion of it. Maybe 10 minutes. That was lesser than before with the new kinds of problems we got to do. Let's look at the vocab and core concept check questions, and then we'll go into the main problems 3 through 41. Let's complete the sentence here. When a graph of a quadratic function y equals f of x has no x-intercepts, the equation f of x equals 0 has 2 imaginary or non-real solutions. Non-real or imaginary solutions. It never crosses the x-axis, so it doesn't have real solutions with that. Number 2, can a quadratic equation with real coefficients have one imaginary solution? Explain. No. We didn't really get into this. Excuse me. I don't know if the book really got into it either. The answer is no. If I only have one imaginary solution, see, notice they talk about real coefficients. Look at all these equations right here that we're talking about. These are all real coefficients. You don't see any I here. You can even see square roots, but you don't see I in any of these, and you won't. They just won't deliver you problems where the initial coefficients and constants have imaginary parts. They'll be real. Now, the only way for them to be real, and you probably saw this in section 4.6, you'll see it in your answers, that whole plus or minus part, the answers come in conjugate pairs. They come in conjugate pairs. No, they come in conjugate pairs. And they come in conjugate pairs because when they multiply with each other, whether or not there's an x involved in the factorization, when they multiply out, the i's cancel out. Either the terms with I cancel out and the I squared term becomes -1, things like that. You end up getting a real solution out when they come in conjugate pairs. If they don't come in conjugate pairs, then you wouldn't have all real coefficients. You would have some imaginary, and we don't have those. And they're not talking about it with those. They're talking about real coefficients. They won't have one imaginary solution. They'll have 2 conjugate pairs, or 2, at least for quadratics. That's where that plus or minus part is involved. And that's where it happens with irrational solutions as well. We've seen a bunch of irrational solutions, but rational coefficients, and they come in conjugate pairs. 2 plus or minus 5 root 7, whatever it is. That's how they show up. Okay. All right, guys, we're going to jump into the main problem set now. And I don't know, we might have to get our calculator ready depending on what we're doing with the problems, but we got problems 3 through 41. I'll go through them using any method that I so prefer based on what you heard in the past. So get ready. Here we go. We are going to start with, and I got to figure out where I'm going to write. We're going to start with numbers 3 through 6, where we use the discriminant to match the quadratic equation with the graph of the related function, then describe the number and type of solutions of the equation. Now, they say use the discriminant to do this. Now, there is a bit of process of elimination that you could do early on based on the y-intercept. They do say use the discriminant, but it's important that I look at A and B. And this is just speaking beforehand. A and B both have 2 real solution sets. That means they'll have positive discriminants. Using discriminant alone won't tell me. It won't tell me which answer is which. That number won't give me a good heads up on what it is with discriminant. So I'm going to have to do a little bit more. What is that? Y-intercept will be a bigger question for me to be able to answer this. I can look at probably all 4 y-intercepts and know exactly what it is, right? But they say use the discriminant, so we're going to start with that. So number 3. Number 3, we have x squared minus 6x plus 25 equals 0. And I didn't see any questions like this on the thing, but they did say use the discriminant, so that'll be part of our practice. So for b squared minus 4ac, discriminant, we're going to do negative 6 squared minus 4 times 1 times 25. That's 36 minus 100, which is a negative number. It's negative 64. It'll have no real solutions. So no 0 real solutions, which means we're going to find the graph that does not cross the x-axis at all. That answer is C. You can look at graph C. Doesn't cross the x-axis because we have a negative discriminant. That's an example of no real solutions, never crossing. Number 4. Now, on number 4 and other questions like it, where there is a greatest common factor, I'd love to divide everything out for my own sake. 2x squared minus 20x plus 50 equals 0. But I do have to use the original graph when it comes to its y-intercept stuff. You just got to be wary of that. Something happened with my pen here. If I divide everything by 2, I get x squared minus 10x plus 25 equals 0. So while these two equations both have the same x-intercept answers, if there are any that exist, this one will. It's a perfect square trinomial. Although that's the case, when it comes to graphing, if we look at these graphs, the y equals this equation is the one that's actually graphed. When it comes to y-intercept, I'm really looking at y-intercept of 50, not 25. Anyway, as far as the discriminant goes, I'm going to do b squared minus 4ac. Looks like this time 100 minus 100, which is 0. And that's going to give me one real solution. The one real solution answer is the one where you cross the x-axis only once. That is D, selection D. It crosses just once there. And that seems to align with the y-intercept of 50. When you look at this graph going up there, and this is 35, it looks like it would hit higher up at 50, whereas these other ones don't quite do anything like that. You can see the first one, number 3, by the way, hitting at 25. So that seems to make sense with that answer. But of course, we're showing other work on this. Number 5. 3x squared plus 6x minus 9 equals 0. Once again, this is one of those, I have a greatest common factor, so I'm going to work off of that thing. I'm going to divide everything by 3 and get x squared plus 2x minus 3 equals 0, which is factorable, by the way. This can actually help me get the answers that way, but they do say discriminant, so we'll keep going in that form. So we'll get b squared minus 4ac, which is 4 plus 12, which is 16. 16 is not only a positive number, which means 2 real solutions, but because it's a perfect square, that does mean this has rational solutions, which means it was factorable. But 2 real solutions, again, we don't know which one's which quite yet, unless you did look at the y-intercept of the original being negative 9. That must be this one here. These are going by 2s, negative 2, negative 4, negative 6, negative 8, and negative 9 right there, so it must be A. The other reason why I think it could also be A, actually that's not a perfect example to look at, but just looking at the stretch factor. Stretch factor of 3 versus this one having a stretch factor of 5. Now this one looks narrower than the other one, but you have to remember the scale of this one. This goes by tens. So that's another way to kind of give away what that possibly could be. It goes by tens, so it'll look more compressed when in reality it's actually not, while the other one just goes by 2s. So anyway, there's another thing to look at. 5x squared minus 10x minus 35 equals 0. All the greatest common factor of 5. Divide everything by 5. Let's get this thing started. Did you do that right? I believe so. It does not look factorable. Does not look to have a real solution. So we'll take a look at that. That is discriminant of b squared minus 4ac, which is 4 plus 28, which is 32. Now 32, 2 real solutions being a positive number. By process of elimination, also we can say this answer is B. Also, y-intercept of negative 35 seems to be what this guy was right here, halfway between negative 30 and negative 40. So yeah, that's how I differentiate between 5 and 6 unless you're actually solving, which I could have solved number 5 by factoring. But that's how I saw them. Number and types of solutions. Yeah, so I did all that as well. I'm sorry. I did that without knowing I was supposed to, but I found the number of solutions there as well. Okay, numbers 7 through 20. This is where we solve using any method. This is probably the meat and potatoes of the kinds of questions you would be doing here. So having 14 of them, I don't mind. And I don't expect I'm going to be using quadratic formula on a lot of them, or on the majority of, on all of them. In fact, this first one, I'm going to solve using square roots. I'm going to subtract 49 from both sides. Oh, explain your method of choice? No, I'm going to say it out loud. I'm using square roots. Actually, I'm going to put it right here, in S. That's an S for square roots. Subtract 49 over, and then take the square root of both sides. This will be plus or minus square root of negative 49, which, whoops, this is not an x squared anymore. This is now x. When I take the square root of both sides, and then this is plus or minus 7i. So I stressed this on section 4.6. The only difference between the square root of 49 and the square root of negative 49 is the square root of negative 49 has an I in it. It's the only difference. What would be the answer if this said plus or minus square root of 49? It would be plus or minus 7. So that's kind of the nice part about this. You're not really learning anything new per se, especially in this section. You're not learning anything new. But even 4.6, we didn't really learn anything new. We just knew to put an eye on it. And that's kind of what we're doing here. If the solutions are non-real, there's no expectation that all these will be non-real. We saw all non-real, but I'm looking at this problem here. I don't think this one's non-real. I'm going to solve using square roots again, by the way. I'm going to add 7 to both sides, and I get 4. Divide both sides by 2, I get 2. That's positive. When I take the square root of both sides, this is going to be as it had been in the past. There's no I in this problem. X is plus or minus root 2, and that's it. So that's an example of don't just assume an I is thrown into the mix, and don't just say, oh, it's supposed to have I because this is the section, or I learned about I's. No, that's not necessarily how it works in these problems. I'm going to move to the next page. Let's go to number 9, where I have x squared minus 4x plus 3 equals 0. Same thing. This is factorable. That not only means there won't be i's in the solution, that there won't be i's in the solution. This is x minus 3 times x minus 1. I'm solving by factoring here. Zero product property would say x equals 3 and x equals 1. So cool. I really like that they're just saying, here's every kind of quadratic equation we can give you. Rational, irrational, real, non-real, that kind of stuff, and just solve. Straight up. This is really nice. This is a really nice problem set, and I'm glad that we have 14 of them. So we really get to budge in to say, some will be like that, and some won't necessarily. 3x squared plus 6x plus 3 equals 0. I already see where this is going. I'm going to probably solve by factoring, y'all. I'm going to add, divide everything by 3. And you have your choice, but this is factorable. This factors to x plus 1 quantity squared. You can argue that this is solving using square roots as well. I either factor or take the square root of both sides at this point, but I say solving using square roots if it's already at that stage. Now it's at that stage. Take the square root of both sides, or you're looking at basically x plus 1 equals 0, or x equals negative 1. Still no i's on that problem either. Just number 7 so far. I expect some i's to pop up next. Number 11 doesn't look factorable and probably looks non-real. X squared plus 6x plus 15 equals 0. Because it's a 1x squared, because the 6 is an even number, I'm going to solve by completing the square. I'm going to go ahead and find the number. It gives me a perfect square trinomial. While I subtract this 15 over from both sides, I will be adding a 9 to both sides here. Divide 6 by 2, which is 3. Square it, you get 9. This factors to x plus 3 quantity squared, and this is negative 6. So when I take the square root of both sides here, yes, this will be imaginary. We will get x plus 3 is plus or minus I root 6. And then I subtract the 3 from both sides. You get x equals negative 3 plus or minus I root 6. So I go with completing the square. You have two options, completing the square or quadratic formula. I went with completing the square. You'll see me do completing the square in all those situations when it's non-factorable, and I have a 1x squared. I can get it down to a 1x squared with an even linear coefficient. If not, I would use quadratic formula. This looks like it may be a quadratic formula problem unless it's factorable. I'm curious. I'm going to test factorization. 3 and 2, 6 and 1. No, non-factorable. Let's go with quadratic formula here. I'm going to begin with the discriminant being b squared minus 4ac. Not only is it not factorable, it also appears it is non-real. Non-real would always mean non-factorable. Oh, I should have seen that coming. So, but I'm not going to stop. We're not done at this stage, right? We used to just say, all right, no real solutions, we're done. Nope, now we go ahead and finish our solving. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so that becomes 2 plus or minus. Now it's going to be an I, right? This is I root 20, and root 20 is 2 root 5, so it becomes 2I root 5. That's what's going to go here. So plus or minus 2I root 5 all over. Now this is 12. If I kept it as 2 times 6, you could see where the 2's will clearly kind of divide with each other. Whoops, not 16. But I'm going to go and turn it into 12 and then divide it all by 2 again. 2, 2, and 12 can all divide by 2, so this will be x equals 1 plus or minus 1I root 5 all over 6. and that is the simplified version of this. That's where simplifying the radical comes into play and helps us out. Quadratic formulas seem to be the good go-to on that one versus completing the square. All right, let's look at number 13. 9x squared plus 17 equals 24x. You can't divide by 3, not with the 17 at least. I will be subtracting that 24x over. And now the question, I never subtract, yeah, so 24x over. Now the question is it factorable? Doesn't look like it. 17 being a prime number. Doesn't really work with these here. If this was a 26, actually it would have been factorable, but it's not. I'm going with quadratic formula again. The numbers will be bigger. So regarding discriminant, we're going to be doing, let's skip the next line. Discriminant, we'll be doing b squared minus 4ac. That is, I think, 576. 576 minus 68 times 9, 626, I think. I have to check that. Did I say 68 times 9? That would be 6. That let me get my calculator. 4 times 9, maybe 672. It's in 17. 612. 612. I did something wrong in my math there. 612. Which is 46. Yeah, kind of a weird number. Let's just be sure my 24 squared my subtraction is good. 36. See, I'm not mathing well right now. So 36. Haven't made a video in a while. Negative 36. Negative 36. So, no real solutions. We're going to come up with the complex solutions, though. What's good about this one, though, 36 is a perfect square. Doesn't mean your answers are rational, just because of the nature of this. This will be x equals negative b, so 24, plus or minus square root of negative 36 is 6i. All over 2a, 2 times 19 is 18. So these can all divide by, I guess, 6, right? So 4 plus or minus I all over 3. Nice, that cleans up. All right, that's my number 13. Okay, let's keep going forward. Number 14, halfway through this set. Not the whole set, just this block. Negative 3x equals 2x squared minus 4. I'm going to add the 3x over. You've seen me do a lot of let's keep our a positive. So equals 0. Non-factorable. For sure. Non-factorable. So I'm going with quadratic formula again. I don't know if I stated last time I was going to do quadratic formula, but I did. So 3 squared minus 4 times 2 times negative 4, 4ac. That'll be 9 plus 16 times 2 is 32, which is 41. Totally non-factorable with that in mind. So we're going to do x equals, listen, I'm going to give you the answer straight up now because 41 is a prime number. That won't work. Negative b, negative 3, plus or minus root 41. I was going to say I. No, it's not imaginary. So root 41 all over 2a. 2 times 2 is 4. So there's the answer. Let's move that up. Let's move that up here. I hope I didn't make a mistake there in my work. That seems legit. I'm going to go with it. Let's go to number 15. I have what looks like it'll be a perfect square trinomial. I just got to move some things over the right way. Negative 10x equals negative 25 minus x squared. I'm going to add x squared over and then add that 25 over. Now you could leave the 25 on that side and use completing the square stuff, but this is already a perfect square trinomial. This is x minus 5 quantity squared. So I'm solving this by factoring. X minus 5 quantity squared equals 0. This is where x equals 5. Just one solution. Just one solution there. Number 16. Negative 2x squared minus 5 equals negative 2x. Let's add these over, make the a positive. I get 2x squared minus 2x plus 5 equals 0. Is not factorable. I'm going to do completing the square this time. No, I'm not. I'm going to use quadratic formula, actually. I would have if factoring out the 2 left me with an even number. But here we go. We got discriminant of b squared minus 4ac, which is 4 minus, looks to be imaginary, 40, which is negative 36. We've seen that number. Negative 36. Okay, so this will be x equals negative b plus or minus the square root of b squared minus 4ac, boom, all over 2a. My a was 2, so 4. Everything can divide by 2, and we get 1 plus or minus 3i all over 2. That's where we go from there. All right. Number 17. I didn't get to do a lot of completing the square yet. And I won't here. Negative 4x squared plus 3x equals negative 5. Let's add that, subtract that over. Positive 4x squared minus 3x minus 5 equals 0. Non-factorable. So let's go with quadratic formula. We're going to do b squared minus 4ac. Looks like real solutions though. That'll be 9. Oh, this is the discriminant, by the way. This is 9 plus 80, which is 89. Perfect. Non-perfect square means non-factorable. This will give me 89 is also a prime number to my knowledge. This will be x equals negative b, which is 3 plus or minus the square root of 89 all over 2a. 2 times 4 is 8. And it looks like we're all good right there. Again, 89 being a, I think it's a prime number. So I can't simplify it at all. Even if it wasn't prime, there are no perfect square factors that can go into it. So as long as I added correctly, then we're good. Let's go to number 18. We have 3x squared plus 87 equals 30x. I'm going to subtract 30x over, and I'm really hoping, I think 87 divides by 3, plus 87 equals 0. It does, but it's 29. So I'm going to divide everything by 3, and I get x squared minus 10x plus 29 equals 0. Not factorable. I'm going to solve using completing the square this time because I do have that 1x squared and the negative 10x. So here, while I subtract the 29 over on this side and I add the same thing over, negative 10 divided by 2 is negative 5. Negative 5 squared is 25. My value I'm going to use to completing the square on both sides. This factors into x minus 5 quantity squared. We've seen that before. And this is negative 4. When I take the square root of both sides here, I do get x minus 5 on the left. And on the right, I'm getting plus or minus. And this is 2i. Square root of 4 being 2 and being imaginary there with the I. So I'm going to add 5 over. We get x is 5 plus or minus 2i. Glad to get another completing the square problem in there. There we go. That's good. Number 19, I have negative z squared. Let's see if we can fit it on this page. Negative z squared equals negative 12z plus 6. Doesn't look factorable. Let's add the z squared over. Z squared minus 12z plus 6 equals 0. Completing the square. Yeah, let's go for it again. So z squared minus 12z plus blank equals, subtract that 6 over, negative 6 plus blank. Completing the square. Let's do divided by 2 is 6. Squared is 36. And 36 on both sides. Real solutions. This will factor to z minus 6 quantity squared equals 30. So real solutions from a positive number. Let's take the square root of both sides. 30 does not simplify. 10, 3, 5, 6, 30 and 1. No, it can't simplify, but we do get the plus or minus square root of 30. And add the 6 over, we get 6 plus or minus square root of 30. Oh, okay. There's our number 19. And last one from this set, number 20. Next page. Looks like it's ready for quadratic formula if it's not factorable. Negative 7w plus 6 equals negative 4w squared. Let's add the 4w squared over. In case it is factorable, this might help us out. 3 and 2. I don't think it's factorable. All right, let's go for quadratic formula. Discriminant is, that's a D, is b squared minus 4ac, which is 49 minus, not factorable, non-real solutions here. 24 times 4 is 96. 96, which is negative, why am I so bad at these days? 47? Negative 47. So I think we can answer this all in one fell swoop. This is a prime number, to my knowledge. Negative b is, so 7 plus or minus I root 47, right? That's the thing we're taking the square root of. That doesn't simplify, so that's all good. All divided by 2a. 2 times 4 is 8. And that's your final result on number 20. Okay, hopefully those all panned out and were correct. Let's keep moving forward. Error analysis number 21. Describe and correct the error. I want to guess what their error is beforehand. I'm covering the thing. I'm going to guess they don't put an I in the answer. Let's see. That's exactly what they didn't do. All right, x squared plus 10x plus 74 equals 0. So you notice their discriminant's negative. I'm going to trust their math is correct. Well, I shouldn't. 100 minus 296 is negative 196. Yeah, that's all good. It's the correct B. It's the correct A. So their discriminant is a negative number, yet they have two real solutions because I is absent. No, I am absent. I is absent from the solution set. Let's italicize that I. Italicize the I. So let's correct that. I mean, I'm going to go on the part where they last were correct. So last correct thing they had was negative 10 plus or minus square root of negative 196. All divided by 2. Now, the square root of 196 is 14, but with the negative 196, it'll be 14i. So that's what we're going to put. What they did was correct thereafter. They kept going on the problem. You can do negative 10 plus 14 and combine it. It's 4. Negative 10 minus 14 is negative 24. Divide them by 2 and you get those answers. So they correctly went through the rest of the problem with the mistake. We can't combine an I with a non-I, so the best that we can do here on out is reduce the fraction. And so this will be plus or minus 14i over 2. Both of these can divide by 2, and we'll get negative 5 plus or minus 7i, but we can't go any further than this. Them going further, negative 5 plus 7, negative 5 minus 7, that's where they get their answers, but because we have an I, we can't. But you should if you are in their scenario. I'm not saying more what we shouldn't be doing here. I'm saying more of do what they did if you do get those kinds of answers, because my students will stop. They'll go like, we leave it, negative 10 plus minus 14 over 2. No. Negative 5 plus minus 7. No, what is negative 5 plus 7? What is negative 5 minus 7? That's where you go. All right, number 22. Reasoning. Write a quadratic equation in the form ax squared plus bx plus c equals 0 that is the solutions x equals 1 plus or minus I. That's what they're going for there. So x equals 1 plus or minus I. Now, this might sound confusing the way that I'm going to go about this. You've seen us do problems like these before where if we move everything to one side of the equation, those are the factors that exist in your answers, and if we expand it out, you can see the answers. But if I move all of these terms over, then you have a trinomial that's squared, and there's a lot more work to do. So I'm going to do this. I'm going to keep I on this side of the equation, and I'm going to subtract the 1 over. Instead, I'm going to treat this more like a completing the square kind of question, or reverse completing the square, solving using square roots, that kind of thing. I guess solving using square roots. I want to square both sides now, just like we would have taken the square root of both sides from this scenario to have something like this. Now, when you square a positive or negative, it turns positive, but I squared is negative 1. So the plus or minus part can be ignored, but I squared itself is negative 1, and here I have x squared minus 2x plus 1. Now this I squared is negative 1, so when I add 1 over, I'll get x squared minus 2x plus 2 equals 0. And that is an equation in this form that has that. And when you go the other direction, when you solve by completing the square, you would get those two answers from that. And that's what we get. Now they say write a quadratic equation. This isn't the only answer because I can triple all these. I can multiply them all by negative 1. But these are that's the essence. That's the ratio of your coefficients that you should have there. All right, numbers 23 to 28, find the zeros of the function. These should be no different than what we did on numbers 7 through 20, with the exception of the very first step, which is where we have to set the y portion, the f of x, the g of x, all that, equal to 0. Everything else should be the same. They do not tell us or ask us to explain our method. I will probably continue and tell you which method I'm going to choose, though. I'm setting this equal to 0. I'm going to solve using square roots. So 5x squared equals negative 35. Subtract 35, divide both sides by 5, and then take the square root of both sides. And we'll get x equals plus or minus I root 7. So yeah, no different from the other problems. Now we just got to set it equal to 0 ourselves. Just one manual step and you're all good. So they're not only testing you on, they're testing you on knowing what that means. Otherwise, it's more the same. So g of x equals negative 3x squared plus 24. Setting it equal to 0. I'm once again going to solve this thing using square roots. So square roots, and we will get negative 3x squared equals negative 24. Divide both sides by negative 3, and it's a positive 8. So when we take square roots, see, this is another reason you don't want to take square roots early. You want to isolate this thing and make sure that you know that we're about to get into positive territory when before it looks negative, and it really wasn't. Take the square root of both sides, you get plus or minus. There's an I, right? Or excuse me, there's no I. There's no I, right? And this is 2 root 2. 2 root 2. All right, number 25. No longer can we use square roots for the rest of these problems. Maybe completing the square, and I'm eyeing that for number 25. Number 25, we have h of x. No graphing so far. Fingers crossed. H of x equals x squared plus 8x minus 13. Let's set that guy equal to 0. It's not factorable. I'm going to solve by completing the square, because I'm going to add that 13 over. Divide 8 by 2 is 4. Squared is 16. Add 16 to both sides. This factors to x plus 4 quantity squared. At this stage, it'll look like solving using square roots, of course. That's what completing the square has on the back end. Taking the square root of both sides, we get x plus 4 is plus or minus square root of 29. Real solutions there. Cannot simplify. Subtract 4 over negative 4 plus or minus the square root of 29. Those are the two answers. And, I want to stress the importance again. I mentioned it back on number 2, way back on number 2, about imaginary solutions coming in conjugate pairs. Irrational solutions will also come in conjugate pairs if your coefficients were real. The plus or minus means two different answers with this irrational part. These are conjugates of each other. They clean up, and they're not irrational in the original problem when they come in conjugate pairs like that, which is also true of imaginaries. So that's where the plus or minus comes, and we've seen it this whole time. I just wanted to stress the importance of that. You won't have just one answer. It won't just be negative 4 plus root 29 or negative 4 minus root 29 all on its own, basically. Number 26. R of x equals 8x squared plus 4x plus 5. Sure don't look factorable as we set this equal to 0. Looks like quadratic formula is the way to go here. We have a discriminant of b squared minus 4ac. Yep, doesn't look real either. We're going to get 16 minus 160. Yeah, which is negative 144. Okay, so a perfect square in and of itself, but being negative means imaginary. So our quadratic set will be x equals negative b plus or minus. Square root of 144 is 12, so you'll get 12i all over 2a. 2 times 8 is 16. Everything here can divide by 4, so you'll get negative 1 plus or minus 3i all over 4. Okay. I feel like we had that answer before. Maybe it was something close. Number 27. Bigger numbers, but I see a common factor of 5 I'm going to be taking care of in just a moment. Number 27, we have m of x equals negative 5x squared plus 50x minus 135. I'm going to set it all equal to 0, and then I'm going to get out my greatest common factor. Now, it's not just a 5, it's a negative 5, and that's good. If I divide everything by negative 5, my x squared becomes positive, which I like. This is 27, I believe. Is that factorable? 9 and 3, no. So completing the square. go completing the square. X squared minus 10x plus a blank equals negative 27 plus a blank. That'll be 25 and 25. Looks like imaginary solutions on the other side. This factors to x minus 5 quantity squared, and this is negative 2. When we take the square root of both sides, we will be getting x minus 5 is plus or minus I root 2. So x is 5 plus or minus I root 2. Excuse me. Number 28. R of x equals 4x squared plus 9x plus 3. Not factorable? Nope, not factorable. I'm going for quadratic formula. Set it equal to 0. Solve quadratic formula. Discriminant is going to be b squared. Looks like we might have real solutions though. B squared minus 4ac. So we get 81 minus 48. 33. 33. No, that can't simplify further. So I'm going to go straight for our answer here. X equals negative b, so negative 9 plus or minus root 33 all over 2a, all over 8. So can't simplify more. That's all we're going to have. Okay, there's that set. All right, next 4 questions. 29 to 32. We find a possible pair of integer values for a and c. This was like an example set before. Such that, let's go to the next page, so that the quadratic equation has the given solutions, then write the equation. Now this is open-ended, but come up with your set based on what your discriminant provides. So if you didn't come to the lecture portion with me beforehand, just listen up on what I'm going to do. All right, we need 2 imaginary solutions. 2 imaginary solutions. So for my discriminant, I need my b squared. I need my b squared minus 4ac to be less than 0. It needs to be negative, the discriminant portion, and then all will pan out. I don't need to dig more deeper into this than that. And we're not doing trial and error until we kind of broken down as much as we can. So the b is 4. We don't know a and c, but 4ac, I mean, we're going to come up with a and c, but we don't plug anything in. So it's going to look like that, right? If I subtract 16 over and divide everything by negative 4, then I will get 4 on this side. But the inequality flips when you divide both sides by a negative number. So a times c has to be greater than 4. And I believe our example did the same thing. It had to be greater than 4. So our product has to be greater than 4. This is very open-ended, guys. You can choose any 2 numbers with a and c. They can either both be positive or both be negative, but they have to be non-zero. As long as when you multiply them, it's greater than 4. Let's say that a is 5 and c is 12. I mean, why not, right? So they say find integer values and write the equation. So 5x squared plus 4x plus 12 equals 0. I mean, I'm pretty well versed in what I can do. Listen, if you know those 2 imaginary solutions, you can make a and c just be monstrous. That will make that big enough. But this is kind of the test that we're going off of here. Number 30. And there are other little tips and tricks that I'm well aware of, and I'm sure that this discriminant stuff will help you recognize what that is when we do these more. But ax squared minus 8x plus c equals 0. We want 2 real solutions. 2 real solutions. So this time our b squared minus 4ac has to be greater than 0 in this case, right? We want positive ones for real solutions, so 64 minus 4ac. Let's go. Let's subtract 64 and divide everything by negative 4, and ac has to be less than, this time, 16. So the, is that right? Yeah. So here's the idea. Right, I could say A is 1 and C is 8, and I'm good, right? And I can, and I will, and I should, and all this stuff. But you know what else is less than 16? Now, here's the thing, guys. You do want A to be 0. They want a quadratic equation. So A has to be that. But C could be 0. C could be 0. C could be negative. A could be negative. If one or the other is negative, the product is negative. So listen, I could have A be 2, and I could have C be not 30, but negative 30. C can be as large as you want, because you know what happens when you do the minus 4ac? Subtracting a negative becomes addition. That way you're never going to get something that's negative. So you could have something like that. I mean, you could go gung-ho with this, right? So 2x squared minus 8x minus 30 equals 0. Man, yeah. And if you're really just writing what I'm writing here, then, I mean, I want you to think for yourself, right? I'm telling you why mine works, but I want you to come up with your own. So mine's very random. I might go basic for one of them. One real solution, you might be restricted to what you can use. It might not be so open-ended. And I could tell you exactly the numbers that I'd have to put for one real solution right now, because it has to be a perfect square trinomial. Ax squared plus 10x equals c. Now this one also has one other little bit to it, which is that c is on the other side of the equation, but one real solution. We have to subtract that c over. So ax squared plus 10x minus c has to equal 0 there. So for one real solution, your b squared minus 4ac, 10 squared minus 4ac. This time c is, negative c. Right? So because the original c that they wrote, they said write the equation probably in the original form. So this gets a little tricky on how we want to say that. The c that I put in is the number that's going to go on that side, but being negative c is kind of weird. But anyway, this has to equal 0. The discriminant this time equals 0 for one real solution. So 100 minus 4. So this minus negative will be a plus, right? Plus 4ac. Subtract 100. And divide everything by 4. You get AC equals negative 25. So I need my A and my C to be a product that equal. Okay. I guess there is more than one answer, because you can have a different kind. There are two different kinds of perfect square trinomials you can have. Now I'm going to keep my A positive in this case, but notice how the product's negative. So I'm going to give myself one of two options here with a positive A. Either A is, there are three, because I guess there are a few. But A is 1 and C is negative 25. Or something like A is 5 and C is negative 5, like that. You could have A be 25 and C be negative 1. Okay, so there's more than one answer for sure with that. But if I have, x squared plus 10x equals negative 25, or 5x squared plus 10x equals negative 5, you can see this is a perfect square trinomial when I add 25 over. That's x plus 5 squared. And when I add 5 over here, 5 is a common factor. It becomes x squared plus 2x plus 1, also a perfect square trinomial. So either of those totally work out. Either that one or that one. Something of that nature. All right, and kind of coming up with some for perfect square trinomials. Cool. Number 32. Number 32, we have negative 4x plus c equals negative ax squared. They're really fooling with us when it comes to the appearance of this. Two imaginary solutions. I'm going to add ax squared over, make that positive so everything feels much better. Ax squared minus 4x plus c equals 0. So we're going to deal with our b squared minus 4ac. It has to be less than 0 in this case for imaginary solutions. 16. Wait, didn't we have this before? Okay, well. All right. 16 minus 4ac is less than 0. Negative 4. This time I'm going to write different numbers, though. Negative 16 divided by negative 4. AC is greater than, as we divide and switch the inequality, 4. Let's make sure I switch the inequality in the other one. I did. Okay. 4. So this time let's change some numbers around. Let's make A equal 3 and C equal, I don't know why I'm overthinking this. C equal 5. All right, so my original equation looks like that. So negative 4x plus 5 equals negative 3x squared. Notice how it says negative a. If a is 3, then it would look like that. That's the original equation. Obviously, if I added 3x squared over, things change a little bit. Okay, and that's number 32, and there's that problem set. Now we have some word problems and the like as we move on. I think we have about 9 more problems overall. How long have we gone so far? Hopefully not overzealous. No, less than an hour. See, it's going pretty well. Let's see if this doesn't slow down too much. In 33 and 34, write a function that represents the situation. So they just say write a function. They don't ask you to solve. So a gannet, never heard of it. Maybe it's pronounced gannet. A gannet is a bird that feeds on fish by diving into the water. Isn't a peregrine falcon? Oh, I'm thinking of now of what's Scuttle from Little Mermaid? Like that one. Apparently, according to the live action one, it can breathe underwater for a little while. Again, it spots a fish on the surface of the water and dives 100 feet to catch it. The bird plunges toward the water with an initial vertical velocity of negative 88 feet per second. Because it dives, it has that downward motion. Okay, so how do I want to say this? Your height equation with respect to t, it starts with this. I don't know if okay, I guess because it's a dive, here's all I was going to say. Because it's a dive, they probably kind of close their wings in, and then they let gravity take hold. So they're not flying downward, meaning it's not like a linear speed. They're letting gravity do it, so I'm still going to use that. I was wondering if they were tricking us. But negative 16t squared plus v naught t plus s naught. Basically, the idea, we need initial velocity, we need initial height. So your initial velocity in this case is negative 88 feet per second. That's the initial. Negative 88 feet per second. And then the s naught, the initial height, it says it dives 100 feet to catch it, so that's 100. So the final equation should be h of t equals negative 16t squared minus 88t plus 100. And there's nothing they're asking us to solve for. They just say set it up, and that's it, right? Write a function that represents the situation. Boom, we're done. We're probably going to set up our own later to solve, but we're practicing here. Number 34. An archer is shooting at targets. The height of the arrow is 5 feet above the ground. Due to safety rules, an archer must aim the arrow parallel to the ground. So with the same initial stuff here, this time we're going to get a v naught initial velocity of 0. It's not that, I should say feet here. It's not that the arrow doesn't move. It has plenty of horizontal velocity. It's shooting outward super fast, but this is vertical velocity. This is a height equation. It's not a model of anything else. It's height with respect to time. So it's going to fall just as fast as an arrow that you just drop to the ground. It's going to fall just as fast. It may shoot outward, but it'll reach the ground just as fast. The initial height is 5 feet. So same kind of equation, gravity takes hold here, but with an initial velocity of 0, that will not appear in your equation. Gravity does, negative 16t squared, but then it's just plus 5. And that's it. That's all we have for the setup. Okay, number 35. Now I think we're probably going to take the word problems and solve. Set up, make our own and solve. Number 35. A lacrosse player throws a ball in the air from an initial height of 7 feet. The ball has an initial vertical velocity of 35 feet per second. Does the ball reach a height of 30 feet, 26 feet? Explain your reasoning. So I'm going to begin, oops, I'm missing the C. I'm going to begin with the model, the equation. This is h of t equals negative 16t squared plus 35t plus 7. All those things come into play. Now it asks, does it reach these heights? Let's start with 30 feet. 30 feet. We're going to set the height to 30, so negative 16t squared plus 35t. Well, let me just say 30. 30 feet. When you do 30 equals negative 16t squared plus 35t plus 7. I'm not going to do the whole quadratic formula, but I am going to do the discriminant portion. And in order to do either of those, you have to set this equal to 0. So I'm going to move all these things over to make this positive. So I'll have 16t squared, positive 16t squared minus 35t, and then subtract the 7 over, you get 23. I've done this a lot in, I forget what section, but I probably 4.5, but I've done this in a lot of previous ones before. It's all about the discriminant. B squared minus 4ac. Is b squared minus 4ac positive 0, or is it negative? If it's positive or 0, then it does reach the height. If it's 0, it doesn't. And I'll tell you what, it's probably not going to reach on this one. I'll tell you why in a moment. But if it does, then it makes the other answer a lot easier. I think that's really a part of it. 35 squared, I think, is 1225. I don't know this part, though. 64 times 23. I thought I brought a calculator home with me instead of using this computer one. 1472. So it'll be negative. Listen, I don't care what the number is. It's negative. So, no, it doesn't reach the height for 30 feet. The reason I was going to guess no is this. If it does reach 30 feet, then that means it will also reach 26 feet, which means I won't have to show work for the second one. And listen, I won't show work for the second one if I don't have to. I'll just tell you, use the discriminant, do it for yourself. I'm not going to spend time doing it. It's all about answering the question. So just like this, I don't care what the number is. Calculate it for yourself. I know it's a negative number. Hopefully that makes sense. 26 equals negative 16t squared plus 35t plus 7. So I'm going to do the same thing, right? I add the stuff over. The only difference here is instead of 23, it'll be 19. Now, that might change a lot, right? Because now for the discriminant, that b squared minus 4ac, negative... Oh, this is a negative 35. That's not going to change anything, but negative 35 squared minus 4ac. Now it's 16 times 19 and times 4 and all that. So let's check that calculation out. 64 times 19. That's 1216. So now we have 1225 minus 1216. I'll just tell you that's 9, and that's a positive number. So yes, it does reach that height. Just barely nicks that height, but it does. Or just barely above it. What are we talking about? Lacrosse? Okay. All right, that's number 35. Number 36. A rocketry club. Okay. A rocketry club is launching model rockets. The launching pad is 30 feet above the ground. Initial height. Your model rocket has an initial velocity of 105 feet per second. Your friend's model rocket has an initial velocity of 100 feet per second. Oh. Okay, well, let's do you and friend. You are this model. Friend. So you and friend. Sorry about this. 100 feet per second. So your friend's model will be h of t equals... I should probably just use two different things for this. Instead of height, I should say altitude or something. Or friend of t. Negative 16t squared plus 100t plus 30. I mean, that's the whole point of using function notation is you can use different letters. Does your rocket reach a height of 200 feet? Does your friend's rocket explain your reasoning? Which rocket is in the air longer? How much longer? All right, it's kind of a bit you have to do with these. Now, I'm going to guess your rocket reaches it, your friend's doesn't. Otherwise, things. But who knows? We'll take a look. So for part A, we're going to go and do... we set these equal to 0, right? Or we do that idea, like if we set them equal to 0. You have b squared, 105 squared, minus 4... Wait. The launching pad started feeling above the initial velocity. 105. Oh, I'm sorry. We don't set it equal to 0. I'm being ridiculous. I was like, of course it's going to be positive. So give me 1 second. I'm sorry about that. We're going to set it's equal to 200. 200 equals, okay, that makes a lot more sense. Negative 16t squared plus 105t plus 30. Add this stuff over. We get 16t squared minus 105t plus 170 equals 0. I think it was right before the word problems. I said, cool, we're almost done. And then this is where it really slowed down. So we're going to do our b squared minus 4ac. B squared minus 4ac will be... calculator time. 105 times 30 to the 11 to the 6 plus 105 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 to 105 squared minus 64 times 170. 145. 145. Yes, for you. Now, I probably should use a whole sentence, but yes, our rocket will reach, given that. Well, your friends. Now, the friend is doing the same height. The difference is the b value, 100 squared. 100 squared minus 4ac. Everything else looks like it's the same. So 100 squared is 10,000. So 10,000 minus 64 times that 170. Let's see this one. This will be negative 880. Just that, oh, it's only 5 feet different. 5 feet per second, man, that's different. That's like a different kind of fastball, too. Negative 880. No, your friends does not. Explain your reasoning. Discriminant. Discriminant. Negative discriminant. Positive discriminant. All right, part B. That is a B. Which rocket is in the air longer? How much longer? Well, your friend is there something that I'm missing of this thing? It says a launching pad, your model is initial. I mean, yours is going to be in the air longer. That's the easy part of the answer, but I was wondering if like yours doesn't launch off the launching pad or whatever, but okay, so yours, let's see. My rocket will be in the air longer. I mean, we have to understand that, right? Everything with all else equal, gravity and initial height, I have a greater initial velocity, so mine will be in the air longer. How much longer is where we got to solve these things. Now, these discriminants, oh, it's not equal to 0. We have to do discriminant, or, quadratic formula is going to start getting us kind of along the way. So we have to solve both of these. That's what makes these kind of spend a while. But it looks like there are some greatest common factors that can, well, mine doesn't have a greatest common factor. So let's see here. So for you is me. So for you, it's negative 16t squared plus 105t plus 30 equals 0. I'm going to make that positive. So 16t squared plus 105t plus 30 equals, minus, I didn't change anything else, minus 105t minus 30 equals 0. So now we're going to do the discriminant, and that'll be b squared minus 4ac. I'll just compute that with a calculator because it's a lot of stuff. This is the slowdown, folks. B squared, 105 squared, and then plus minus the negative, so 64 times 30. So 12945, 12945, 2945. No idea whether or not it's a perfect square. I guess it's not, but let's see what it approximates to. Yeah, no, it's not. It's close. It's close to 113. But this is t equals negative b, so 105, plus or minus root 129. 12945 all divided by 2a is 32. Now I'm going to ditch the minus version. That's not relevant to us, so I'm just going to go ahead and approximate what that answer is. So 105 plus the square root of that guy divided by 32. This thing's going to be in the air for about 6.83, 6.84 seconds. I'm getting 6.8367, 6.84 seconds. That's how long mine's in the air. The friends, it's going to take the same discriminant bit. It's going to do, I'm going to basically look at 16t squared minus 100t minus 30 equals 0. And so the discriminant, I mean, everything else kind of changes, but discriminant is negative 100 squared and then minus 4 times 16 times negative 30. So I still have to recalculate that. So 100 squared, so 10,000 plus 64 times 30. I Type the right numbers, wrong numbers here. 64 times 30. So we're getting 11920. Also assuming that's not a perfect square. 11920. So we're going to be doing t equals. So this is 100 plus or minus. Let's just do plus the square root of 11920 all over that same 30, which is approximately plus square root 32, not 30. I'm sorry. 32. And this is about 6.54 seconds. So despite the fact that my rocket hit that 200-foot mark and this one didn't, it's not in the air much longer. 6.84 minus 6.5 really isn't. It's about 0.3 seconds. So, okay. I mean, that's it. So, it wasn't like 2 seconds more or anything like that. I guess that was it. All right, number 37, critical thinking. When a quadratic equation with real coefficients has imaginary solutions, why are the solutions complex conjugates? This is something I answered on number 2 way back when. I've spoken on this a little bit. Why are they complex conjugate? As part of your explanation, show there is no such equation with solutions of 3i and negative 2i. So I kind of mentioned this before. Solutions are complex conjugates because when multiplied out, they create a difference of two squares effect where the middle terms with I cancel out, and the first and last terms square any i's to real numbers, because I squared is negative 1. So that's just an important thing to keep in mind when we're doing that. So let's try it with 3i and negative 2i. X equals 3i, x equals negative 2i. If I subtract them over, x minus 3i equals 0 and x plus 2i equals 0, we're looking at this equation that would have x minus 3i times x plus 2i as your factors. That would mean like a y equals version of this. So y equals x minus 3i times x plus 2i. Now when I FOIL this thing out, we're going to be getting x squared plus 2ix, 2ix minus 3ix minus 6i squared. So 2ix minus 3ix is negative I times x. I squared is negative 1 times negative 6 is positive 6. That part becomes real, but this part did not. Non-real. In a difference of two squares scenario, this would have worked. But notice this is not a real coefficient. Not a real coefficient. But a difference of two squares scenario where it's x minus 2i, x plus 2i, x minus 3i, x plus 3i. The middle terms would have canceled. You still would have had this I squared work itself out. But not here. Not here. And that's kind of the final result of that thing showing it doesn't work. All right. Four more problems. Number 38. How do you see it? Well, the graphs of three functions are shown. Which functions has real zeros, imaginary zeros? Explain your reasoning. F and G have real zeros. Look at F. It crosses at the origin, but it crosses once, and it only needs to cross once. G crosses here and here. H does not cross at all. So F and G have real zeros because their graphs intersect with the x-axis. H has imaginary zeros. Now, keep in mind, F only has one real zero, but that's okay. H has imaginary zeros. Did they ask how many? No. Because its graph doesn't intersect with the x-axis. And that's how I see it. Probably should have typed that. All right, number 39. Using structure. Use the quadratic formula to write a quadratic equation that has the solutions here. -8 plus or minus root, oh boy, -176 all over, -10. Well, I'm going to kind of do some, investigative work here. So x equals -8 plus or minus root -176 all over -10. I'm going to start with the a and b stuff here. First of all, I do not like that they have this negative here. They really should have worked on simplifying some stuff, and but I think they're looking for very specific answers, so that's okay. So this is the 2a part. This would be 2 times -5, which means my a would be -5. This is the negative b right here, negative b. That means my b would be 8 in that case. So it's all about that 4ac. It's all about that 4ac. So a is -5, b is 8. So what is c? C is unknown now. Let's look at the discriminant. Our b squared minus 4ac, b squared minus 4ac has to equal -176. So we'll do 64 plus 20c equals -176. Subtract 64 over, we get -240. Divide by 20, you get c is -12. So write a quadratic equation in that case. That would be y equals -5x squared plus 8x minus 12. All right. 2 more questions. Number 40. Thought-provoking. Describe a real-life story that could be modeled by that stuff. Write the height model for your story and determine how long your object's in the air. All right. Well, you guys make up your own, but let's say I'm a baseball guy. You hit a baseball 3 feet above the ground with an initial upward velocity of 60 feet per second. Okay. Write the height model for your story and determine how long objects in the air. Oh man. Let's say 4 feet above the ground. I didn't know I had to do that. All right, so I should have made it factorable as well. So h, or h of t, is -16t squared plus 60t plus 4. All right, how long is it above the ground? We're going to set that equal to 0. It was a high fastball we hit. I'm going to, not just going to change signs. I'm going to divide everything by 4. -4. I get 4t squared minus 15t minus 1 equals 0. Much better looking. Not factorable, but much better, much better. I could have made it much better even than that. Discriminant will be b squared minus 4ac. 225 plus 16 is 241. There we go. So t equals -b, 15, plus or minus square root of 241, all over 2a. 2 times 4 is 8. Ignore the minus for this problem for how long it's in the air. Here we go. 15 plus root 241. 241 is close to, it's somewhere between 15 and 16 for that number. So this answer will be close to, it'll be a little under 4 seconds, probably 3.7 or so. 3.8. 15 plus square root of 241, probably closer to 3.8. 241 all divided by 8. 3.815. So 3.82 seconds. All right, I solved my own equation. Love it. All right, last question here. Oh, there's a lot. Number 41. The stratosphere, I've been up there. The Stratosphere Tower in Las Vegas is 921 feet tall. Oh, I thought it was 1,000 feet tall. Or more than 1,000. Oh, here we go. Has a needle. Okay, yeah. Because there's, there are rides on the top, and the needle itself is also, it's like a free fall ride thing, so you do go above 1,000 feet at that point. Anyway, Has a needle at the top that extends even higher. A thrill ride. Oh, they're talking about it. I like this. A thrill ride called Big Shot catapults riders. It actually shoots you up. You should check it out. Look up Stratosphere Big Shot. Big Shot. That's what I think. Stratosphere Big Shot. Check out Stratosphere Insanity. I like that one. Okay, a throw ride called Big Shot catapults riders 160 feet up to the needle and then lets them fall back to the launching pad. It does a little bit more. It has motorized, but that's okay. Pretend like it has gravity take hold. The height, they give you information. The height of the rider can be modeled by this. There's initial velocity in feet. Find V naught using the fact the maximum value of H is 921 plus 160 equals 1,081 feet. What? Oh, it's not 160 feet initial velocity. It's not feet per second. That's how much higher it goes. Okay, I gotcha. So our initial model that we have is our height with respect to time is negative 16t squared. This is part A. Negative 16t squared. That looks cluttered. Plus V naught t plus 921. We're going to set the final height that we get at 1,081 feet and find the initial velocity of that. So negative 16t squared plus V naught t plus 921 equals 1081. Now, when I subtract that over here to the side, I'll get negative 160, or I'll get that 160 we were kind of looking at here, plus V naught t minus 160 equals 0. Now, our goal here is to find that. I'm going to use the discriminant and set this equal to 0. When does it actually reach that purported height? So for my discriminant, I'm going to be doing b squared, squaring v naught, minus 4. Ooh, I shouldn't have kept that negative. That's okay. AC. I will keep it negative because I'm solving for v naught here. We need to set this equal to 0. So our v naught squared, this will be a minus in the end, 25, no, that's not right, 10240? 10240. Let me check that out. 64 times 160. 10240. 10240. Have we seen imaginary numbers in a while? Equals 0. V naught squared equals 10240. And take the square root of both sides, but I don't think it's rational, but it's not. So I'm kind of leaning more toward having an exact answer unless they ask you to round. They don't. So I'm going to keep it as square root of 10240 like that. Feet per second. It's around, I'll say what it's around. It's around 101.19 feet per second. But it's not exact. So I like that they use, why didn't they give you clean, happy, pretty numbers? Because they used actual numbers with this. It must shoot you up 160 feet in the air. That must be a true thing. So that must be how much they actually launch you. All right, part B. A brochure for Big Shot states the ride up the needle takes 2 seconds. Compare this time to the time given by the model where V naught is the value you found in part A. Discuss the accuracy of the model. Time it takes to ride up the needle. So let's put this into perspective. Forget what I said. Let's find the vertex x value by using our equation. We can use an equation of negative 16, h of t, we have our model, h of t equals negative 16t squared. I'm going to use this exact guy, square root of 10240 times t plus 921, the original. We are going to find the x value of the vertex using negative b over 2a. The t value of the vertex. So for the vertex, the t value is negative b over 2a. Let's see what that's about. So negative square root, sorry that you can't see this, so I have a negative 32. I'm getting around 3.16 seconds. So that's far off from 2 seconds. Discuss the accuracy of the model. The brochure is 1.16 seconds faster than the model, at least the reporting thing, because 2 seconds is 1.16 less than 3.16. That's not really all that close. Okay, and that's it. All right, guys, that ought to do it for this one. Sorry, you can't see that. That ought to do it for this one. This is Mr. Robinson. Thank you so much for watching. It's less than an hour and a half. Pretty good. Not everything here was about I, right? There were other things that we're talking about. A lot of things with discriminant. But not everything was about I, but it's solving any kind of equation now. Any kind of quadratic using any method, whether it has I, whether it doesn't have I, and I think that's the point of it. So I really liked this set with it. I hope you did too. And I hope it's all starting to make sense a little bit more, or you're starting to understand my work and philosophies with them. Anyway, guys, thank you so much for watching. Take care. I will see you in the next one.